Good afternoon, everyone. My name is Katano. I'm from NetApp. So for today's session, myself, Katano from NetApp, and we have Mr. Masaki from Yahoo Japan. So this is a joint session from two companies. So for speakers' profiles, so Masaki-san, can you introduce yourself? Yes. I'm from Yahoo Japan. I'm a storage engineer. My name is Masaki. In my first year, I was assigned to appliance storage operation team. There, I was handling the storage device operation, and also I validated OS for the new components as well as the NetApp storage. Same time last year, I was assigned to private cloud team. So it's been a year since I involved myself in the OpenStack operation. So now I belong to private cloud team. So I validated the back-end storage and storage components. I develop and OpenStack Cinder and Swift related solutions. So my name is Katano. I'm from NetApp. So I'm responsible for telecom carrier and ID service industry customers, and I'm also the sales or the pre-sales SE, and so I'm responsible for Yahoo Japan account. Again, I'm from NetApp. So this is the joint session, and also this is a community session. So the Yahoo is using the NetApp solution and OpenStack, and they're using the OpenStack in a large-scale commercial environment. So we would like to cover how to use this kind of storage solution in a large-scale environment, and also for some of the points for future consideration for you. So this is today's agenda. So first of all, so we're going to talk about how the Yahoo Japan decided to introduce the OpenStack in their system and how they are currently using. And we'll also talk about the important points for the consideration when it comes to storage. And after that, so I will talk about the requirements for Cinder in OpenStack storage environment. So without further ado, Masaki-san, floor is yours. So from my side, I will talk about our approach for OpenStack environment in Yahoo Japan. So as you know, in addition to Internet portal side operation, we provide a lot of other services. So it's important to offer the services swiftly and also while maintaining the stable operation. So I will talk about our insight. So let me talk about how we have decided to use OpenStack. Before OpenStack deployment, we were using our the homegrown IaaS environment as a private cloud, but there's a lot of issues with that. First of all, API format is proprietary, and also it's quite difficult to develop the IaaS environment and operate with the limited amount of resources, and so therefore we have to allocate a lot of the human resource for the operation, which is slowing down the new functionality development. At the time of the release, of course, that devices are aging, and there's a lot of the advanced function incorporated devices, but in order to use that, we had to create a new environment so that we can really have a better life cycles. Therefore, in the beginning of 2013, we started paying attention to an OpenStack and a CloudStack, and we started the validation. Back in 2013, in Asia, CloudStack was more popular. But outside of Asia, the OpenStack was more popular. So after the validation, so because of the flexibility for the custom development and also the information availabilities, and we have decided to choose an OpenStack. So 6 months after we started the validation of the OpenStack, we were able to release the OpenStack in our development environment. So it's been 2 years since we started using the OpenStack in our environment. Here's the reason why we chose the OpenStack among all of the IR software. As I pointed out, there's a great momentum in OpenStack adoption globally. Earlier stage, there are not much software available for the OpenStack, but there's a strong user community in Japan. They're holding the seminar and the workshop. And even we encounter some issues by asking the question to other users and vendors, we are able to solve the solution. Well, we come up with solutions. So we are the largest OpenStack users here in Japan. And for some functionalities, and we don't have much choices for the hardware in the back end. In these cases, we asked the extra work to vendors, so the vendor prepared some unique driver for that. So this is the verification to deployment. In Yahoo Japan, so we are able to release a development environment 6 months after our validation. I'll come back to this point later. By moving into OpenStack environments, so through OpenStack API, we are able to manage the data center. And in a several dozen seconds, we can start several hundred instances. And after the release of development environment, and 6 months later, we released a production environment. For the service side of members are already used to using OpenStack. So several days after release, we are able to again deploy the service in an open source OpenStack environment. So the reason why we're able to deploy this environment in a short amount of time is because we don't have to prepare the unique API. In our traditional environment, we had to develop the basic functionalities and also the additional minor functionalities. And for account integration, we had to do everything by ourselves before. But after OpenStack implementation, well, we can tap into basic functionality in the communities, and for some minor functionalities, we just outsource the minor functionality development to vendors. So only thing we would do is that user-related functionalities for our private cloud. So that's the only thing we take care of. So we have completed a lot of the custom functionalities. So now that we are making the greater contribution to communities. So if you look at this slide, and so using the OpenStack platform, we are distributing these content. And so this is the current services running on the OpenStack. So Yahoo Japan provides more than 100 services. And most of the services are running on the OpenStack platform. So this is not the new, and most of the services are already running on OpenStack for a year. Some of the instances are constantly running, but an Olympic or Soccer World Cup or general election, so have a lot of high access hike, so that temporarily we enhance the instances. So the reason why we can do is that because of the OpenStack advantage, which is enabling us to manage the large-scale resource pools. You can see the T-shirt, so it said "Bakusoku," that the explosively fast. So that our slogan or vision is we have to meet at a rapidly changing environment. So application release cycles and for OpenStack is more proactive for the environmental changes, so that we have a great affinity with the OpenStack philosophy, with Yahoo's slogan. So here is Yahoo's current OpenStack utilization. So currently Yahoo Japan, so we are running 4,000 compute nodes. You can see this is the user survey results, and so that you can see the Yahoo's position here. In addition to computer node, computer core, 96,000 for instance. So you can see the 50,000. So looking at the survey results, we are among the top tier users, so that we can say that we are the heavy users.
So next is about our private cloud service service offering status. Under our environment, there are development environment and production environment instances. In total, we have about 50,000 instances, maybe half and half for the development and productions. So those instances availability is 99.996%. So this is satisfying the quality level. Currently, traffic density has grown 6 times comparing with the physical environment. The data volume capacity is 20 petabyte, and the cluster offered is about 20 clusters. This 20 cluster is quite liquid, so there are some closed clusters or newly built clusters as well, and overall they are cycling the life cycle or rolling the life cycle. So there are 11 team members managing this private cloud. There are some members who have been in this private cloud team from the beginning, but OpenStack is a combination of the network, server, storage, and so forth, which under the IaaS technology, so infra technology involved members are also in our team. Development and operation responsibilities are allocated, but other than these, we have appliance operating members as well. In case of the troubles on the OpenStack, the private cloud team responds. However, when it comes to the actual device problems, the relevant team members try to solve those issues. So each team members are collaborating closely. This is a user usage status. In Yahoo Japan, we have about 2,000 engineers in all services that we are offering. And all those engineers, we offer the IaaS environment in equivalent manner. When the VM causes failure or performance degraded, the Office OpenStack operation team swiftly respond to those. Private cloud team, as a part of the IaaS environment proliferation activities, we periodically hold seminars. This was close to the engineers in the beginning, but recently we see the interest from other team members, and they have started to participate. Maybe thanks to this seminar effect, this usage is proliferating over the engineers, non-engineer employees as well. And there are about 500 instances operated in a day. However, in a month's time, half of this is vanishing or eliminated. Probably because it is a self-service environment, they deploy with some space or room, and after the release, they eliminate those. And in a private cloud environment, all are operated by ourselves. So, in comparison to the public cloud operation, the cost was significantly reduced. Under the regular specification, you may not see a huge difference, but the specification that we require, which is about 2 core memory, 12 gigabytes under Yahoo. So with this capacity, the difference is huge. So rather than using the public cloud, we have reduced the cost by 97%. So in regard to the operation status, I would like to give you a tip. This is a photo of the Tokyo Tower, which is a radio tower, very famous one in Tokyo. Under our OpenStack, we use the storage component, which is consisted of the Cinder and a small size Swift. So if we overlay all the disks, it adds up to 377 meters. Tokyo Tower is 333 meters, so our disk number is higher, or our disk height is not higher than this Tokyo Tower. So next, I would like to talk about the benefit of using OpenStack. First of all, the standardized API can be used. By using the standardized API, we are able to leverage the OSSs around it. To date, these areas had been prepared by ourselves, so new IaaS environment establishment or new development was slowed down. However, recently we are able to allocate more people to the areas or layers closer to the applications. This is another benefit for the users as well. So leveraging the internet knowledge, they are able to utilize this technology in easy-to-use manner. The second benefit is a vendor-neutral resource utilization. OpenStack has various vendor participations, and they have OpenStack unique drivers as well. So we have more options on the hardware resources, and that's able to have the abstraction of the hardwares. Thirdly, the data center abstraction. OpenStack implementation allows us to reduce the time of the time required for the orders or delivery for the servers. So like securing or wiring network design, those things that need to be considered by the users are no longer necessary, and thus deployment of the machines became easier. And not only limited to the virtual machine offering, but orchestration deploy is possible, so that is a big benefit of having the OpenStack. So this is an image of how we offer the service to the users. User use the virtual machine via the control panel that we prepare. Basically, the resource management is done by the operation side, and the user side released from the cumbersome activities such as to select the devices or the ordering those. So clustered data center or hypervisor types of production or development or storage network, they just need to choose out of the box that is prepared. So if they have particular requirements for the SSD for the application, they send the request to us and we provide the service. So when the resource is reduced, we are installing new clusters without any time downs. So the integration interface that we are offering is as shown here. This UI offers the basic functionality of the OpenStack and the cluster-based residual resource static information of virtual machine search functionalities are on here. Availability zone-based usage status can also be confirmed. Initially, you may not need the virtual machine, but as you grow larger over time, you need to consider the disaster recovery and distribute the data in both East and West virtual machines. So this would be a useful tip for you in such event. So this UI allows the startup of the cluster-based deployment. So this is the hypervisor environment that we are currently using. This is a KVM environment. KVM environment is created using Chef. The OpenStack version-based recipe is prepared so that the most optimized status is provided for the configuration. When it comes to the large-sized clusters, more than 200 hypervisor setup is required, but with Chef, only one command completes the deployment. Also, under the KVM environment, availability zone-based flavors are prepared. So, depending on the request from the user, a number of IOPS or reduction of latencies is sent to us. Therefore, we prepare the devices depending on their request. Sometimes we offer the SSD device, or sometimes NVMe is offered. Other than these, in combination with the backend used storage, the storage's benefit should be maximized. So the Cinder driver prepared by the vendor is also used. This is a VMware ESXi environment. Recently, VMware ESXi used environment is released. VMware uses vCenter to allow the integration management of the ESXi under the vSphere environment. If you use a VDS, VM access can be switched by the data center unit. The benefit of the VMware is the high redundancy. VMware functionality has the VMware HA, but when the parent server fails down but the healthy server can self-restore this, so you can reduce the downtime of the instance.
VMware のプラグイン
By using that VAI, that VMware plugin, so we can maximize the functionality of the storage at the back end. So instance image is stored in the storage side, so there's no performance degradations. And for when you start the instance, so there's some cloning at the storage side for image, so that therefore we can eliminate unnecessary traffic there. Hence, we can reduce the I/O. So this is the component selection consideration. So in a company, there are 3 key points we pay attention whenever we choose the storage component. When we cannot stop I/O. Second, the time required for instance cloning. Thirdly, for the vendor support. That we cannot stop the I/O. That's very important for the business or service continuity. Some of our services includes the lifeline support, so this is the significant point. Even there's some failure, we have to continue the service in the front side. So in the back-end operation side, we recover and using the failover and failback functionality. And same thing is applicable to maintenance. Rolling update. So the update while maintaining the services is an important criteria for component selection. The time required for the instance cloning is one of the most important criteria for storage selection. If we consider auto-scaling, again, we cannot neglect this factor. And vendor support is of the great importance when it comes to component selection. We have numerous types of the services, and there's a lot of the requirements for the service operation side. And to meet the requirement by ourselves, it's a lot of work. Therefore, we need a vendor who can listen to outside requirements and a vendor who can collaborate with us to meet the end user's requirements. So that's why this is another important criteria. This is our Cinder implementation, and there are 3 key points. One is the shorten the time for instance cloning in the back-end storage, and we are using the clone technology so we can start the huge volume of instance in a short time. The second is the storage installation per availability zone. So we have a different kind of the power distribution in the data center, so that we separate the availability zone per power distribution line. So in the same way, we locate the storage. So when the user starts the instance, the user just pay attention to availability zone for the parent HP, and they can set the redundancy between the instances. Therefore, if the one power line goes down, so the other power line is live, so therefore, again, that operation can be maintained. Third is the multi and back-end configuration. So we are pretty open to the storage in the back end. So we're using the appliance storage at the back end. So for the stability and easy to use, so the appliance is our best option. But software-defined storage is It can be the one of our choices as well because of the technology advancement, and we are the early adapter of the new technology. So nowadays, that SDS have some technology, and so for the other component and other one of the different kind of integration. So that's quite important or interesting point. So far we have talked about that OpenStack environment in our side. So let's talk about why we have decided to use the NetApp storage. Outside of OpenStack environment, we are the heavy user of the NetApp. So we have a lot of engineers who have a good knowledge of NetApp. So that's one of the important reasons. So because some of the components are designed to protect the data, such as Cinder and other. We have drivers such as FlexClone, which can leverage the NetApp functionalities. These drivers, we don't have to change the API in OpenStack, so that can reduce our development workload. So we have, again, the diverse services in IaaS environment. So I believe the FlexClone is a quite beneficial technology. And even before we move to the virtual environment, we have been using the NFS, Common File Storage. The NetApp is quite strong in this area. So Manila Common File Storage component is attractive choices from NetApp. Therefore, and again, we have to have a very collaborative vendors for the continuous support, so that we can accumulate the knowledge and experience. So we call it just co-creation. So just to symbolize our relationship with NetApp. So now I'd like to hand over to NetApp person to talk about consideration points for storage selection from NetApp perspective. So this is a storage requirement specific to IaaS environment from a NetApp perspective. So when it comes to OpenStack environment storage requirement, I think there are two perspectives, perspective of infrastructure and perspective from IaaS environment. For the infrastructure side of requirements, and there are some general requirements, high availabilities, simple manageabilities, and scalabilities. And also, well, when the Monster VM emerges, we have to make sure that Monster VM doesn't really have any impact in other VM, so you have to have a finer I/O control in a large-scale cloud environment, and that data volume is quite high in the storage, and the system disruption has a huge impact on the user side. So therefore, we have to minimize the system outage and as much as possible, and for the user's benefit. So if we consider self-service portals, and do you think is a requirement? So NetApp has the in-depth experience in this area, especially we have a cluster architecture at the same time. For self-service portal requirement, well, we have to understand how the users are using the self-service portal. So the OpenStack users, they create a tenant from the self-service portal, such as Horizon. So for number of instance and number of CPU core and storage capacity, it's set per tenant. So here's what users do for tenant. Commonly done work is the instance creation, and so the creating the backup using the snapshot and the template upload. Traditionally, These are handled by an IT department for the virtualization, for instance, for the backup. Sometimes the backup puts a higher workload in the system. So usually that backup is captured at the night time for the job execution. So the VM creation, same. If the several hundred VMs are created and started at the same time, and that puts the workload on the host and network side. So if we cannot offload from the storage, and that has a huge impact in the system side of performance, so that has to be considered. In a self-service environment, again, so we have to really understand the additional workload which is potentially coming from the self-service environment. So as I pointed out, so these are common work done by users and VM replication and backup using snapshot and template upload. By connecting this to storage functionalities, so the VM replication, so the VM can be replicated without consuming any resource, and for snapshot, without creating data, so that there's no performance degradation for the snapshot creation, and for the data traffic via host and network, so that it's possible to offload the workload in a storage side.
前には強力なストレージの仮想化機能を連携することでデータ生成自体を極小化して
Virtualization capability, so all the data can be offloaded to the network, and overall infrastructure can be flexibly or stably utilized. So this is about the KVM environment. NetApp offering the Cinder driver for the KVM environment. NetApp Unified driver is offered. This unified driver is leveraged to back up the snapshot or data offload or virtual machine cloning, linking it to the FlexClone. So given the time constraints, let me skip this slide. Next, I'd like to talk about the VMware environment. So this environment is when it is controlled by OpenStack, when it is used of ESX driver or vCenter will be used. So in case of the Cinder usage, VMDK driver is leveraged to boot the instance or create the SSS. Vendor provided Cinder driver no longer be usable under this environment. That can be a problem. Therefore, the virtual machine replication would be done through the vSphere, and VMware snapshot would be created. Of course, the traffic cannot be uploaded. And the virtual environment plugin tool that we offer, Virtual Storage Console, the backup capability is offered by that. So these tools are no longer usable under this environment. So the self-service portal requirement, how we are able to satisfy this requirement? Basically, VMware environment native functionality needs to be used. Therefore, vSphere and storage are linked, which is VAI or NFC VAI, or recently released Vivo. Those new technology are leveraged. That is a very important factor. What is written on here is the integration specific details. This is a network-based linkage. In case of the virtual machine cloning or replication, NFCR or Vivo can be used for the linkage with the FlexClone without degradation with the capacity. VAI could also be used, but VMDK used cloning SK usage is better for this application. And in case of the snapshot, unfortunately, VAI or NFC VAI function would not supplement this capability requirement. So V/6 released Vivo usage needs to be considered. By using Vivo, VM snapshot can be linked to the snapshot, the VM clone. But this is a new functionality, so how you deploy this functionality needs to be done with great caution. Lastly, data creation offload. So this functionality, VAI or NFS VAI, can be leveraged for this offloading. So with this, KVM vSphere environment have been explained. But hypervisor, depending on which hypervisor you use, the functionality you need to utilize will be different. So hypervisor, the storage, which has a relation or linkage capability, it needs to be chosen. And you have to clarify the requirement for the self-service environment. Lastly, we would like to ask Mr. Masaki again to talk about his future initiatives. So let me talk about the future schedule. We would like to proceed with Manila. The shared file system is demanded within a company as well, and Manila allows the file sharing over the tenant. And Hito-based auto-scale time, you are able to create the common shared file system. So I think there are ways to utilize this. And this shared file system has been widely used since the physical era, and there are many. It is easy to implement the service. And there is no end to this utilization or this service. And those users who are not able to migrate towards the IaaS, I think this is a great feature. Lastly, let me wrap up this session. The benefit of the OpenStack is that the standardized API utilization and hardware resource utilization and data center abstraction. And the storage component provides the availability, efficiency, and safe environment. So the vendor storage should be used, which has a proven record and know-how. And for the convenience improvement for the OpenStack environment, the co-creation with the user and vendor is very crucial. So that concludes our session.
If
there are questions, please contact us. We will be here. So please contact us directly. Thank you very much for your attention.